Welcome back to the deep dive. We have quite a stack of reports in front of us today,
We really do.
and they all paint a picture of something pretty unique that's happening right now in the tech landscape.
That's a good way to put it. Unique is definitely one word for it.
We're looking at an open source project that went from, what, a quiet hobbyist experiment
Yeah, basically one person's side project.
to over 100,000 GitHub stars in roughly 8 weeks.
8 weeks. It's a trajectory that, you almost never see that. It's warp speed.
But the star count, as insane as that is,
Yeah.
it isn't really the story here, is it?
No, not at all. The real story is the divergence, the split personality of this whole thing.
What do you mean by that?
Well, usually when a project grows that fast, it's because everyone agrees on what it is,
Yeah.
It's the next big thing, the next big framework. Everyone's on the same page.
Right, it solves one problem really well.
Exactly. But this is a totally split reality. On one hand, we've got these case studies from places like Femex and Orpay, and they're showing a single user, one person, generating $115,000
In a year.
in a single week using this tool.
$115,000 in profit in 1 week.
In 1 week. So you have this incredible, almost unbelievable financial engine.
And on the other side,
On the other side, you've got this pile of security reports. We're talking Info Security Magazine, a deep dive from a researcher called 6 Mile.
and they're not talking about profits.
They're talking about a completely chaotic landscape. Trademark battles, $16 million rug pulls, and, actual malicious malware that has infected hundreds, maybe thousands of users.
So that's the split. It's either a gold mine or minefield.
Depending on the day, yeah.
And the project we're talking about is called OpenClaw.
That's its current name anyway.
Right. And our mission today is to really unpack what the industry is starting to call the agentic economy.
It's a big buzzword right now.
It is. And we need to move past the buzzwords and actually understand the mechanics. Like, how does a piece of software living on your local Mac Mini end up holding the keys to your bank account?
And maybe the bigger question is why? Why, despite these massive security risks we're about to cover, and they are significant, they're not trivial,
Right.
why are people still trusting it? Not just trusting it, but trusting it with their life savings, with their digital identities. It's a huge leap of faith.
It really is.
Yeah.
So let's start at the absolute ground level. What actually is OpenClaw? Because you mentioned it had other names, formerly Molebot, and even before that, Claudebot.
Yeah, the naming is a whole story in itself. We'll definitely get to that.
But functionally, what are we looking at? If I download this today, what does it do?
Okay, so to really get OpenClaw, you have to understand the shift from chatbot to agent. It's a really important distinction.
Okay.
Most people today are used to things like ChatGPT or Claude. You open your browser, you go to a website, you type a question.
And you get an answer.
Right. And what happens is your text gets sent to a massive server farm somewhere in Virginia or Oregon. The server thinks, it processes, and it sends text back to you.
So it's a conversation. It's fundamentally passive. The AI is waiting for me to talk to it.
Exactly. It's a remote brain in a box. OpenClaw is different, fundamentally different. It's a self-hosted AI agent.
Self-hosted, so it's not on their servers, it's on mine.
It's on your hardware. That's the key. We're talking about your Mac Mini at home or a Linux VPS you rented for $5 a month or...
The docs mentioned a Raspberry Pi 5.
Yeah, or even a tiny Raspberry Pi 5 sitting on your desk. And here's the kicker. It doesn't just talk. It does. It's active, not passive.
What do you mean it does?
It connects to your file system. It can read your documents. It connects to your terminal so it can run commands. It connects to your applications, your calendar, your email.
So if ChatGPT is like a consultant you call on the phone for advice, OpenClaw is an employee you hired who is sitting in your office and they have a key to your filing cabinet.
That is the perfect analogy. Absolutely perfect. And that distinction, that employee in your office, brings up the first major technical pillar of this whole thing, data sovereignty.
Right, because the data isn't leaving my house.
Precisely. This is why the privacy crowd absolutely loves it. Your files, your calendar appointments, your personal notes, your to-do lists, none of that ever leaves your server. It stays local.
But it still needs to talk to a large language model, right? It's not running Llama 3 on a Raspberry Pi.
Correct. The only thing that goes out to the cloud is the specific prompt. So, the reasoning part of the request gets sent to an LLM API like Claude or GPT-4, but the execution, the context, and all the data storage happens entirely locally. Your data stays yours.
Okay, that makes sense. So let's get under the hood a little bit more. The documentation mentions something called the lobster shell, which, fits the theme.
It does.
What is that? How is that actually functioning differently than, say, a standard Python script I might write to automate a simple task?
Yeah. It all comes down to the loop, the process. A standard script is, it's linear. It's deterministic.
Meaning you tell it what to do step by step.
Exactly. You're right. Do step A, then do step B, then do step C. If step B fails for some reason, the whole script just crashes.
Yeah.
It's rigid.
Right.
The lobster shell runs a continuous process loop. It's always listening. And the loop goes something like this. Message input.
So me texting it.
Right. Then intent detection, where it figures out what you actually want. Then context retrieval, where it looks up relevant memories or files. Then tool selection.
And that's the important bit.
That is the magic moment. Then execution, and finally response.
So that tool selection phase,
Yeah.
that's what changes the game, right? It's not me telling it which tool to use.
Exactly. It's probabilistic, not deterministic. You aren't programming the exact path. You're just giving it a goal.
For example.
You could text it, plan a trip to Tokyo for next June, and put the travel dates on my calendar.
A normal script couldn't handle that. It's too vague.
Right. But the agent looks at that, and it looks at its toolkit, its available skills, and it thinks, okay, to do this, I probably need to use the web search skill to look for flights. Then I need the parsing skill to pull out the dates and times. And finally, I need to use the Google Calendar API skill to create the event. It figures out the steps on its own, dynamically.
So it's improvising a plan based on the tools you've given it. It's reasoning.
Yes, and it remembers. It learns from what it did, but how it remembers is also really distinct. The Contabo technical guide highlighted this, and I think it's just fascinating from a design perspective.
It's not a normal database, is it?
Not at all. OpenClaw completely rejects complex, opaque databases. There's no SQL server, no complex vector store that you need a computer science degree to query.
So where does it keep its memory?
It stores its memory, its configuration, its entire history as simple markdown files in folders.
Just plain text files.
Plain text files.
That feels very old school. It's the old Unix philosophy, isn't it?
Everything is a file. That's the Unix way, baked right in.
What are the implications of that?
It means that if you want to debug why your agent bought the wrong crypto token or why it misunderstood a calendar invite from 3 weeks ago, you don't need a special database viewer. You don't need to run a query.
You just open the folder.
You just open the folder, click on the text file for that day, and you can read the agent's thought process in plain English. It's incredibly transparent.
You're literally making the brain of the AI readable by a human.
You are. Which is amazing for debugging and trust. But, as we'll definitely get into later, that transparency, having everything you need in plain text files, is a massive double-edged sword when we start talking about security vulnerabilities.
I can imagine. Now, in terms of interface, you're not just sitting there typing into a command line on your server, are you? That doesn't seem very practical.
You can, but that's not where the real power is. The power is in the integrations. It's designed to live where you already chat.
Like what?
It connects via API to basically everything. WhatsApp, Telegram, Discord, Slack, Signal. There's even a bridge for iMessage.
So you're telling me I could be at the grocery store, I'd pull up my phone, open Telegram, and just text my home server?
Precisely. You could text, hey, check if that server deployment from this morning finished successfully. And OpenClaw, running on that little Raspberry Pi on your desk at home, will SSH into the server, check the logs, and text you back. Yep. All good.
That collapses the distance between you and your personal infrastructure.
Completely. It makes your home server as accessible as a contact in your phone.
And what if I wanted to do something new, something it doesn't know how to do out of the box? I assume that's where these skills come in.
Right. And the ecosystem for that is called ClawHub. Think of it exactly like the App Store for your agent. It's a repository of these plugins or skills.
So I've wanted to control my smart lights. I go to ClawHub and download the Philips Hue skill.
Exactly. Or a skill to interact with a specific crypto exchange or post to social media.
Now, the sources compare this model to another automation tool I've used, which is N8N. But N8N is very visual. It's all about flowcharts.
Yes. And that's the key difference. NAN is structured. You drag a box for new email, and you draw a line from it to a box for create Trello card. It's incredibly powerful, but it's rigid. You define the workflow ahead of time.
It's a fixed process.
Yes. OpenClaw is conversational and ad hoc. You don't build a flow. You don't draw any lines. You just text it. Check my flight confirmation email from yesterday and book an Uber to the airport for that time.
And there's no pre-programmed flight to Uber pipeline that I had to build.
None at all. The agent just figures out the connection on the fly. Using the skills it has installed, it chains them together based on your intent.
So NAN is like a train track. It's very efficient, but it only goes to one predefined place.
That's a great way to put it.
OpenClaw is more like an off-road vehicle. You just point it at a mountain and say, get over there.
Yes. And as we're about to see when we talk about its history, sometimes off-road vehicles drive right off a cliff.
This architectural transparency and this raw power, it's obviously very appealing. But the project's history is anything but clean and simple.
No, it's a mess.
And the sources refer to this early period as the Great Molt, which I think is a perfect name for it. It's a case study in what happens when a hobby project slams into high-frequency financial incentives and, pure internet hype.
It really is. And it all started, funnily enough, with the name, with trademark law.
So the project was created by one person, Peter Steinberger.
Right. And initially it was just this little hobby project called Claudebot. That's C-L-A-W-D bot.
Claudebot, which sounds very familiar.
It sounds exactly like Claude, as in the AI model from Anthropic. And Anthropic, quite reasonably, their lawyers reached out to Steinberger and said, hey, can you please change the name? This is going to cause a lot of confusion.
Okay, that's a fair request.
Totally fair. So he pivots. And he leans into this lobster theme he's been developing, this idea of a hard, protective shell with a soft, intelligent interior.
So he rebrands to Moltbot.
Moltbot. Metaphorically, the lobster is shedding its old shell. It's clever. It's a good name.
It is.
But the execution of the digital rebrand, the actual switchover, created a complete disaster.
This is the incident. The part about the handle sniping.
Right. So Steinberger controls the official account on X, the platform formerly known as Twitter. It's @Claudebot.
Okay.
He announces the rebrand. He tells everyone, we're moving to Moltbot. Then, to complete the move, he has to drop the old handle @Claudebot so he can then register the new one @Moltbot.
He has to release it to claim the new one.
But in that tiny window, and we are talking about milliseconds here, between dropping the old one and trying to claim his new one, he got sniped.
Can you explain how that even works? Because to a normal person, you just assume you drop a username and it's free for anyone to grab.
Well, you have to understand there's a whole underground market for high-value usernames. And there are professionals, they're called handle snipers.
That's a real thing.
It's a real thing. These are not people. They are automated bots that are constantly monitoring the APIs of social media sites for high-profile accounts or desirable dictionary words. The absolute millisecond the X API registers that @Claudebot is available.
A sniper bot grabs it.
Instantly, before any human could even type it. It's effectively high-frequency trading, but for digital identity.
And these snipers, they weren't just squatting on the handle to hold it for ransom. They had a plan.
Oh, they had a very specific plan. This is where the agentic economy meets the scam economy. The new owners of the @Claudebot handle immediately used the account, which, remember, still looked official to anyone who hadn't seen the rebrand news in the last 5 minutes.
So it still had all the old followers, the history.
Exactly. They used that trust to launch a fake crypto token. They called it SLOD, and they launched it on the Solana blockchain.
And because of the insane hype around the project at that moment?
People devoured it. They thought it was the official token launch. People were throwing money at it. The fake token hit a $16 million market cap. $16 million.
In a matter of hours. Just based on pure FOMO, people thought, oh, this viral AI agent project is launching a token. This is the next big thing I have to get in early.
Wow. And then,
of course, the real Peter Steinberger had to come out from his new, much less followed account and publicly disavow it. He had to tell everyone, I have nothing to do with this token. It's a scam.
And the token crashed.
To near zero, instantly. A $16 million evaporation.
That perfectly highlights the blast radius you mentioned earlier. In this new ecosystem, a simple digital fumble like losing control of a username for a few seconds, it doesn't just mean embarrassment anymore.
Right.
It can mean millions of dollars in real, tangible losses for your community, for the people who believe in you.
Exactly. And the chaos didn't even end there. Just to cap off the confusion, the project was under so much pressure from this whole Moltbot fiasco that by the end of January 2026, it rebranded again.
To OpenClaw, the name it has now.
OpenClaw.
So that's 3 names in, 2 months? Claudebot, Moltbot, OpenClaw. Yeah. And that constant change, that sense of chaos, it's exactly the environment where scammers thrive. Confusion is where they make their money.
So we have an incredibly powerful tool with a foundation of, let's say, sand. and we have a chaotic history. But now we need to talk about the immediate present danger. Because while the token scam was bad for investors, the software itself had some very nasty surprises hiding inside.
This is the security nightmare section of our deep dive. And really, if you're out there running an instance of OpenClaw right now, you might want to pause what you're doing and listen very closely because this gets technical and, frankly, pretty scary very fast.
And this all comes from a report from a researcher named Paul McCarty, who goes by the name 6 Mile.
Right. And he decided to do something pretty straightforward. He decided to audit ClawHub.
The app store for skills that we mentioned earlier.
Exactly. He wanted to see what was actually in there. And what he found was alarming, to say the least.
What did he find?
He found 386 malicious skills on ClawHub.
386.
Yes.
That is a massive number. We're not talking about 1 or 2 rogue developers here.
No. This was a widespread, coordinated effort. And the really insidious part was the camouflage, how they were disguised.
They weren't called malware.skill.
No, of course not. They were masquerading as essential, desirable crypto tools. They had names that claimed they were official integrations for Bybit, for Polymarket, for Axiom, even for mainstream things like Reddit and LinkedIn.
So they were skills that the target demographic, these power users, these crypto traders, would actively seek out and want to install.
Precisely. They were Trojan horses built specifically for the OpenClaw user base.
So how did the attack actually work? Was it some sophisticated zero-day exploit in the code?
The delivery mechanism was actually much simpler and, in a way, much more clever. It was a form of social engineering that the security world calls clickfix.
Clickfix, I haven't heard that term.
It's a nasty little trick. It relies on a user's impatience and their inherent trust in error messages.
Okay, walk me through it.
So you, the user, you install one of these malicious skills, say the Polymarket Trader skill. You try to use it for the first time. The skill is intentionally programmed to crash or throw a fake error on the first run.
And it gives you a message.
It gives you a helpful-looking message, something like, oh no, a critical dependency is missing. To fix this error, please copy and paste this command into your terminal.
No, that is devious.
Isn't it?
It completely relies on muscle memory. Every developer, every power user, we've all been there 1,000 times. You get an error, you Google it, you find a fix on Stack Overflow, and you copy-paste a command into your terminal without even thinking about it.
It exploits the debugger mindset. You're not thinking critically, you're just trying to fix the problem and move on. But when the user pasted that command,
They weren't fixing a dependency.
they were downloading and executing an InfoStealer malware package.
And these info stealers, were they just for Windows?
They were targeting everything. Custom payloads for Windows, for Mac OS, for Linux. They were designed to steal browser cookies, saved passwords, and most importantly, cryptocurrency wallet files.
And were they all separate attacks?
No, and this is how we know it was coordinated. They were all phoning home, sending the stolen data to a single command and control infrastructure. The IP address 91.92.242.30 appears in almost all of the reports from 6 Mile.
Which implies a single group, a single campaign, not just a bunch of random hackers trying their luck.
That's right. And one uploader in particular, a user on ClawHub named Hightower6U, had nearly 7,000 downloads across their suite of malicious skills.
7,000. That is potentially 7,000 completely compromised machines.
At a minimum.
This brings us to a quote from Diana Kelly, she's from Noma Security, that really stuck out to me when I was reading these reports.
I think I know the one you mean.
She said, agents aren't just smarter chatbots, they inherit your privileges.
And that right there is the absolute core of the delegated execution problem. It is the single most important security concept for our listeners to understand today.
So break that down for us. What does delegated execution really mean?
Okay. Traditional computer security, for decades, has been built on a principle called least privilege.
Right, you only give a user or a program the bare minimum permissions it needs to do its job, and nothing more.
Exactly. Your web browser doesn't need access to your tax returns, so you don't give it that access. But an agent, a tool like OpenClaw, needs most privilege to actually be useful. Its utility is directly proportional to how much access you give it.
If you want it to book a flight, it needs your credit card details. If you want it to deploy new code to your server, it needs your root SSH keys.
Yes. So to make the agent smart and capable, we have to make it inherently dangerous. There's no way around that.
And when you combine that with this Click6 attack,
You see the problem. If you give OpenClaw permission to use your terminal, and then it downloads a malicious skill that tricks you into running a command, You have effectively automated your own hacking. You've used this powerful automation tool to automate your own destruction.
You gave the burglar the keys, the alarm code, and a hand-drawn map to the family safe.
That's a perfect way to put it. And the problems weren't just in the skills, right? The underlying infrastructure itself had massive holes.
Oh, absolutely. The reports were full of users making basic security mistakes. People were exposing their gateway.ws.
Which is the WebSocket connection, the agent's main communication channel.
They were exposing that directly to the public internet without any sandboxing or firewall.
Mm.
What does that mean in practice for someone who isn't a network engineer?
It means that anyone who was scanning the internet for open ports could find your agent's front door, and if there were any vulnerabilities in that gateway, they could potentially just walk right in and take control of your entire system.
Yeah, there was a massive data leak, too. Not from OpenClaw directly, but a related project.
Yes, a project called Multbook, which was an attempt to create a social layer on top of all this.
Huh.
One of their databases was left completely exposed online. No password.
And what was in it?
1.5 million API keys.
1.5 million.
API keys for everything from OpenAI and Anthropic to crypto exchanges, and 35,000 user email addresses. It was catastrophic.
That's the kind of thing that forces the big players to act.
It absolutely did. Anthropic, the makers of the Claude AI model, they brought down the hammer. They started systematically banning users. Their systems would detect if you were connecting to their API using credentials associated with an OpenClaw instance, and they would just shut your account down.
What was their official reason?
Their public statement cited a violation of their terms of service, something about using their models to train other AI models, but really, let's be honest, it was about containment. It was about risk mitigation. They did not want their cutting-edge AI being the engine powering this incredibly insecure Wild West ecosystem.
So just to recap, we have widespread malware, massive data leaks, coordinated attacks, and now bans from the major AI providers. It sounds like a complete and utter disaster zone.
It does.
So why on earth is anyone still using this? What is the upside that makes this level of risk acceptable?
Because, as with everything in high-stakes finance, risk is simply the price you pay for reward. And the potential rewards here are, well, astronomical.
This brings us to Section 4, the power. And we have to start by talking about the Deegans.
The Deegans, yes. It's short for degenerates, which sounds bad, but in the crypto world, it's often worn as a badge of honor.
It's a term of endearment almost.
It is. It refers to a class of trader that thrives on high-risk, high-reward strategies. And for them, OpenClaw isn't a security risk. It's a personal quant.
A personal quant, as in a quantitative analyst, like having a little Wall Street genius in your pocket.
Exactly. A quant on demand. And the Femex and RPay case studies, they prove that the concept doesn't just work in theory, it works in practice.
The $115,000 week.
That's the one. The proof is in the pudding.
Okay, so let's unpack that specific strategy. How does a piece of software make 115 grand in 7 days? This isn't just about getting lucky on a meme coin, is it?
No, not at all. This wasn't gambling. This was a sophisticated high-frequency strategy. This was market making.
Okay.
The user set up their OpenClaw bot to trade on Polymarket. Now, Polymarket is a prediction market where people can bet on the outcomes of future events.
Like who will win an election, or if a movie will hit a certain box office number.
Right, but this bot wasn't betting on politics. It was trading on the 15-minute price markets for major crypto assets. Bitcoin, Ethereum, Solana, and XRP.
Market making is about providing liquidity, right? You're not betting on which way the price will go.
You're not. You're profiting from the activity. The bot strategy was to constantly place a buy order slightly below the current price, say, buying at 80 cents on the dollar for a yes contract, and at the same time placing a sell order slightly above the current price, say at 82 cents.
And it just captures that 2-cent spread.
It captures the spread, the difference between the bid and the ask.
2 cents doesn't sound like a lot of money.
It isn't, until you do it thousands and thousands of times a day. The log showed the bot was executing up to 12 separate orders every 4 minutes.
12 orders in 4 minutes.
Across 4 different markets simultaneously. It was absorbing all the buy pressure and then selling back into the market faster than any human being could possibly click a mouse.
So that's the key. It's the speed, the inhuman speed.
It's the volume and the speed. The report mentioned this bot had made over 13,000 trades since December. It had cleared a total profit of over $1 million, with that $115,000 spike happening in a single volatile week.
A human can't do that. You can't track 4 different assets, calculate the spread in real time, and update your orders every few seconds, 24 hours a day, 7 days a week. It's impossible.
It's impossible. And this is why people take the risk. If you can set the system up correctly, and if you're lucky enough not to get hacked by a malicious skill, it's a literal money printing machine.
It really is.
Yeah.
And the crazy thing is, it lowers the barrier to entry for these incredibly complex strategies.
Massively. You don't need to be a Python expert or a C++ programmer to do this anymore. All you need is the right skill. In this case, the banker skill.
Right. We did a deep dive into the banker's skill documentation specifically.
Mm-hmm.
And this is where that agentic interface, that conversational control, really comes into its own.
It's a whole different paradigm. You don't click buttons on a web interface. You don't fill out forms. You just text it.
Like you're talking to your broker.
Exactly. The commands are all natural language. You can text your bot, buy $50 of ETH on the Base network, or bridge 100 USDC from Polygon over to Base.
That sounds incredibly convenient, but it also sounds like it removes a lot of safety rails, a lot of confirmation screens.
It removes the, "Are you sure you want to do this?" dialog box, yes. And the capabilities documented for this skill are they're wild.
Like what?
You can text it, launch a token called Moon on the Solana blockchain.
Wait. You can launch a new cryptocurrency via text message.
Yes. The agent will handle the entire interaction with the Launchpad service, setting up the bonding curve, paying the fees from your wallet. It does it all based on one sentence from you.
That's insane.
It gets crazier. You can say, bet $10 on yes for the Trump wins market on Poly Market, or short BTC with 10x leverage with a stop loss at $45,000.
This is what we mean by the agentic economy. It is natural language finance. But, and here's the massive expert warning, this massively increases the risk of fat finger errors.
Oh, absolutely. 100%. If you type a command incorrectly in a terminal, 9 times out of 10 you just get a syntax error. Command not found. It fails safely.
But if you typo a text message to your agent,
It might try to interpret your intent. It might try to guess what you meant. If you accidentally type short BTC 100x when you meant 10x, the agent might just go ahead and liquidate your entire account because it thought you were feeling particularly bold that day.
that is terrifying convenience.
It is.
But it's not just high-frequency trading, right? The sources listed a whole bunch of other use cases, a kind of top 10 list. What else are people doing with this?
Arbitrage is a huge one, constantly scanning for tiny price differences for the same asset on different exchanges, like between Binance and Polymarket. The agent can watch both 247 and execute a trade. The gap becomes profitable.
Okay, that makes sense. What about sentiment analysis?
This one's pretty interesting. The agent scrapes social media, so X and Reddit mostly. It reads thousands of posts and comments about a specific token, determines if the overall sentiment is bullish or bearish, and then automatically buys or sells that token based on the vibe of the crowd.
Vibe-based trading, fully automated.
It's the world we live in now, I guess.
Wow.
Another fascinating one that's a bit more gray hat is airdrop farming.
Right. Airdrops are when new crypto projects give away free tokens to their early users. But they try to filter out bots, right? They want real human activity.
They want proof of activity, yeah. They have things called Sybil detection to stop one person from using 1,000 fake accounts.
So people are using OpenClaw to fake being human.
Exactly. An agent is much better at mimicking human behavior than a simple script. It can automate complex interactions across different testnets, bridging small amounts of funds, swapping tokens, joining the project's Discord, and posting a message. It makes one person look like hundreds of legitimate active users.
And finally, the list mentioned the on-chain sentry.
This is more of a defensive use case.
Yeah.
The agent watches the blockchain for you, specifically for massive whale movements.
A whale being a wallet that holds a huge amount of crypto.
Right. So if a wallet holding $50 million worth of Bitcoin suddenly moves all of it to an exchange like Coinbase, that's a huge signal that a massive sell-off might be coming.
And a market crash.
And your agent can spot that transaction the moment it happens and send you an instant alert on Telegram so you have a chance to get out before the dip.
So on one hand, we have this malware-infested, chaotic, amateurish mess.
A total mess.
And on the other hand, we have a tool that can essentially run a sophisticated multi-strategy hedge fund from your bedroom. That is the duality of OpenClaw.
It is. And it forces us, I think, to zoom out and ask some much bigger, more philosophical questions about where personal computing is actually going.
Yes. Section 5, the philosophy of the agentic economy. Because this feels much bigger than just one piece of software. This feels like a paradigm shift.
It is. I think we are witnessing a fundamental shift in computing, from a model of tool use to a model of delegated authority.
Okay, break that down for us. What's the difference?
Well, for the last 40 years, software has been a tool. Microsoft Word is a tool. It's a better typewriter, but it does nothing until you start typing. Even an automation script is a tool. It only runs the specific, explicit set of instructions you wrote for it.
It has no autonomy.
No autonomy. Delegated authority means the software acts as the human. It makes its own decisions to achieve a goal.
It decides how to achieve the goal. You just set the destination and it figures out how to drive the car.
Yes, and this creates a fundamental head-on conflict with how we've designed and built computer security for the last 20 years.
How so?
Security has always been about locking things down. Sandboxing, isolation, least privilege. That's been the mantra for decades. But AI agents, to be useful, require the exact opposite.
They require opening things up.
To be useful, the agent needs full access to your file system. It needs to be able to execute shell commands. It needs your API keys. It needs access to your wallet.
So to make it smart, we have to make it inherently vulnerable.
That is the core tension. The source we read from Noma Security put it perfectly. The big question for enterprises and for individuals isn't, do we want to use agents? Of course we do. The real question is, do we want the power of delegated execution enough to justify the massive controls and risks we have to accept?
Do you trust the robot enough to give it the master key to your entire digital life?
That's the question. And this philosophy extends all the way down to payments. We talked about the agent holding a crypto wallet, and you have to ask, why crypto? Why can't I just give it my credit card number?
I'm guessing because a robot can't sign a check. It doesn't have a legal identity.
Precisely. An AI agent cannot pass KYC, know your customer regulations at a bank. It can't walk into a Bank of America branch, show a driver's license, and open a checking account.
It doesn't have a face. It doesn't have a social security number.
But it can generate a unique crypto wallet address in milliseconds for free.
And it can hold USDC or Ethereum or any other digital asset without asking anyone for permission.
Exactly. And so, by necessity, crypto becomes the native rail for AI to AI commerce. We are, right now, building the financial infrastructure for an entirely non-human economy.
That is a fascinating, if a little bit dystopian thought. A whole background economy of agents, trading with other agents, buying API calls, renting server time, all completely outside the traditional banking system.
It's not a future thought. It's happening right now, in a nascent form with projects like this.
Okay, my brain is officially full. That is a lot to process. But before we wrap this up, we need to make this actionable for the listener.
For sure.
If someone is listening to this and thinking, okay, I get the risks, but I want the reward, I want to try this, what is the golden rule? What is the one piece of advice they need to follow?
Isolation. Absolute, uncompromising isolation.
What does that mean?
The security experts all agree on this. Do not, under any circumstances, run OpenClaw on your bare metal operating system. Do not run it on your main MacBook where you keep your family photos and your tax returns. Just don't.
So how should you run it?
The bare minimum is to run it inside a Docker container. That provides a basic layer of separation. But even better, run it inside a dedicated virtual machine on a cloud server or a spare computer.
So if the agent gets infected or if it downloads one of those malicious skills,
you can just nuke the entire virtual machine. You burn the container to the ground without it ever having touched your actual important files.
So the mantra is, treat it as hostile code until it is proven trustworthy.
Exactly. Treat it like you're in a virus research lab. Air gaps, firewalls, extreme caution.
And in terms of the software itself?
Verify your sources. Only download the code from the official OpenClaw GitHub repository. Check the commit history. Don't download it from some random forum.
And the token.
And remember, there is no official token. If you see something called OpenClaw or Claude or whatever comes next, it is a scam. 100% of the time, do not buy it.
I think the big takeaway for me from all of this is that we've really moved past that era of tool use, where we are in control, where we click the buttons.
We're in the delegated authority era now.
We're handing over the keys. And the question is no longer if we'll do it, but who are we actually handing them to?
And maybe more importantly, when that agent makes a mistake or gets tricked by a malicious plugin, who's responsible? Is it the coder who wrote the skill? Is it the user who installed it? Or is it the AI itself?
That is the big unanswered question for 2026.
It really is.
Check your permissions, sandbox your agents, and we'll see you on the next deep dive.
Stay safe out there.